So what we're going to do in this video is take a look at getting you ready for the final exam. We're going to go over the practice problems. We're going to do 1 through 11, which basically covers chapter 1 for your final exam. And what I've done for the final exam practice is next to each problem, I tell you what section each problem comes from. And I've color coded the rest of these problems. You'll see when I get there, but I wanted to let you know about that. The first two problems are from section 1.1, and they're with scientific notation. So remember, scientific notation is all about taking your values, big numbers, writing it out a little bit easier to rate, and moving the decimal. 1, 2, 3. Decimal place is over. Here's your answer for that one. Going the other way, 3.521 times 10 to the negative 3. That's a small number. That's a large number. Negative exponent for the small, positive exponent for the large. There's how you do that. Now for number 2, like I said, another one from section 1.1 is to take these numbers and to list them from least to greatest. By the way, your final exam will be multiple choice. These first two are not multiple choice, but it will be multiple choice format on your final exam. So here's what we have. I'm going to leave this one and this one alone written as a decimal. I am going to convert this into a decimal. I'm going to convert this value into a decimal, and I'm going to convert this one also into a decimal. So my values here are 0.000314. That I'm set to go. This one is 0.000237. That one I'm good to go. This one is 30. So starting out with my smallest value, I'm going to look for the most number of zeros after my decimal. This has 1, 2, 3, 4. This one has 1, 2, 3, 4. So the zeros make it a tie. 1 is less than 2 for my tiebreaker. There is my smallest number. Then the one with the 4 zeros and the 2 comes next. These two are gone. Then I have one with 3 zeros after the decimal. That comes next. Then I have one with 2 zeros. And then I have this big number, 30, that by far is the greatest value. Take a look at number 3. Here's where the multiple choice problems start. For number 3, I have marked this up in these different colors. First of all, this is from section 1.2. I am looking in yellow for what the price is now after something has been marked up. So I am looking for the new retail price. If this coat originally was $360, it has been marked up 15%, $360. I am going to move the decimal over 2 places. So I have 360 plus 0.15 times 360. That's the markup or the new price of the coat's increase. 360 plus when I multiply that, get 54. The new price of the coat is $414. So there that problem is from start to finish, starting with the right formula. And where people struggle sometimes is they don't know what formula to go for. But whenever you see the word gone up, wholesale markup, that's the formula you go with. Same for number 4, section 1.2. What is the original price or the retail price? I see the word markdown. I see the word sales price. Have all sorts of clues to what formula I'm going to go with. So the sales price of this item is $54.54. We're looking to see what it originally came down from the original retail price if it was marked down 25% off. So, move the decimal over 2 places. I know this looks like a mess. All of the X's and algebra flying around. We can do, move that 0.25 over. There is my X. There is my 1. Remember, there's a 1 lead coefficient with that X. And what I have is 54, 54. 1 minus 0.25 is 0.75x. Then to knock this guy out, 0.75. Cancel, cancel. So my X value, the original price of the item, was 72.72. My answer, choice B. There's what you have for that one from start to finish. Again, it all starts out with the right formula. On to the next problem. We have number 5 here. What we want to do is to determine which one of these models would be a parabola that opens up. So I'll go ahead and give you the answer to this one. My answer would be choice C, but the reason that it's choice C is because this X is squared. That tells me it's a parabola, and this A value in front is a positive 3. That's what makes me have a parabola that opens up. I'm in section 1.5. Choice A would be linear. X is not squared. It would be linear. That goes down from left to right, slopes negative. Part B, choice B would be a parabola that opens down. X is squared. A is negative, so that would be a parabola that opens down. Choice D would be a linear model. X is not squared. This model would go up from left to right because their slope is positive 3. Section 1.4, a linear model of the amount of lemonade in gallons that this person sells at the lemonade stand. What is the meaning of slope? First of all, the slope is 0.28. What this means is for every customer that comes by, John sells 0.28 more gallons of lemonade because each customer drinks 0.28 gallons. So N is the number of customers. Every time a customer shows up, 0.28 gallons of lemonade will be sold. Number 7, we have to find the vertex of this parabola. This is out of section 1.5. I have this quadratic model that I have to put in standard form before I do anything, and that's what I did. The A coefficient with the X squared must come first, and the B coefficient comes second. So commutative property, I just flip those around. Now I'm ready to go. My B is positive 8. That negative comes from the formula. My A is negative 2. So I have negative 8 over negative 4, which is positive 2. Now, check this out. We have 2, 8, 2, negative 8. My answer is either going to be B or D. Choice A and choice C are out because the X coordinate was negative 2. So I'm sort of playing the system with the multiple choice, helping the format on narrow down answers. To find the Y coordinate, all I do is plug in the X coordinate of 2 into my model. So I have negative 2 times 4 plus 16, or negative 8 plus 16, positive 8. My answer is 2. So there's how you do 7. Number 8, very similar problem to number 7, except this is a projectile motion problem. We have a model. We want to find the maximum height the ball reaches the ground. So what I'm going to do is find the X coordinate, use the X coordinate, plug it in for the Y coordinate, and that would be the maximum height. So this model is in standard form already. I have my B value is 1.6. There's the negative from my equation right there. I have my A value, which is negative 0.1. I have negative 1.6 divided by negative 0.2. My X coordinate is going to be positive 8. There's the trap answer A. That's not what I'm looking for. I'm looking for the maximum height, which is the Y coordinate. I have negative 0.1 times 8 squared plus 1.6 times 8. So what I have is negative 0.1 times 64 plus 12.8, or negative 6.4 plus 12.8 would be positive 6.4. My answer B. There's how you do number 8 from start to finish. Projectile motion, maximum height is Y coordinate. Let's take a look at number 9. What we have for number 9 is to determine which one of these graphs is decreasing exponentially. There is my graph right there. It swoops down. This increases exponentially. So it's swooping up. This next choice would be linear. It's a line. There's the word line. This increases. This last one, a logarithmic model for the graph. So for this particular one, it decreases exponentially. On the final exam, you might have one that increases exponentially or a logarithm graph. It depends, but for the practice final, decrease exponentially. Take a look at number 10. We have an exponential expression that we want to convert into a logarithm. So there's my logarithm. My base is 13, 371, 293 equal to 5. So remember, logarithms are just another way of writing out an exponent expression. And to write this out in English, the logarithm 371, 293, base 13 is 5. So exponent expression, logarithmic expression, English expression, they all three mean the same thing. Last one for this video and last one for chapter 1. We want to predict percentage of adult height using this model for a male between 5 and 15 years old. We're going to pick a male that's 8 years old. All I'm going to do for this model is plug in 8 into the expression. I have 61.8 plus 36 times the log of 4. I didn't do anything fancy on my calculator yet. I did a lot of copying down. The only thing I did was I said 8 minus 4. Now, in your calculator, you have to find the log of 4. So let me review how to do that by using your calculator again. Depending on what type of calculator you have, I have a graphing calculator, so there is my log key. I enter in 4. If you have a cell phone, I think it's 4, and then you hit the log key. Either way, you come up with 0.60. So I have 61.8 plus 36 times 0.602. 61.8 plus 21.67. I multiplied those two guys together. I would get 83.474%. My choice is B. So the next video, we'll take a look at the next review problems from chapter 2 on financial math.